The future is watching. Welcome to Opcode Virtual Summit.
And yeah, and we are back on the thing. Cool. Hi, Mark. Hi, Anastasia. Can you hear me? Okay.
Hey.
Yeah, hello.
Hey, cool. Everything is working good. And I guess we can start.
Yeah, let's just make sure, like, Ruslan,
Yeah,
do you hear us?
I do hear you. I cannot turn on my video though.
Oh. Let me check. Maybe I touched something that I should not have touched.
Oh, there we go.
Okay. That's
hello.
Should be better now.
Hello.
Excellent.
Cool. Well, I'll let you introduce each of you. So let's start with Mark, since he's going to be the main moderator and he's going to be driving the discussion.
A pleasure. So my name is Mark Carney is my real name. I'm not the governor of the Bank of England, although I wouldn't mind the salary, to be honest with you. I work as a security researcher, and I do a lot of work in and around cryptography. You may know me from such controversies as writing a lot of maths to do with the crypto flat earthers at Black Hat last year. So that's something that I did. But no, this is a really good opportunity. Thank you very much.
Hey, thank you. Let me be like the next one. So hello, my name is Anastasia, and yeah, I'm like excited to join. Like Mark, thank you, and Matt, thank you too. It's like a cool idea to do like small AMA. So my background is I have a typical computer science background, and I'm a software developer. But the thing is that I switch to like data security and software security a little bit. So I would say that I'm a software developer with like specific specialization of like applied cryptography and data security. And I work at Kozak Labs, and what I do is I just make sure that the data stays encrypted and like protected for different kind of applications across different kind of infrastructures, languages, and technological stacks, with different, like databases, coding, like languages, I told it again. So yeah, and today, like my approach and like my perspective would be more about applied stuff and like how cryptography looks like from software development point of view, and what software developers typically look at and what they completely miss. Yeah, thank you. Ruslan.
Hey, right. So my name is Ruslan, and I'm originally also from Ukraine. I studied cryptography back in Ukraine as well, and for a while after that, I worked in a team that was developing a new cipher that later became a national encryption standard back in Ukraine back in 2015. After that, I kind of shifted more towards software engineering because I really like the much shorter feedback loop, right? You don't have to wait for years to get some results in. So I guess we are moving to the same spot, trying to fill in the gap between software engineers and cryptographers. It's just me and Anastasia coming from different directions to the same spot, right? She's coming from computer science, I'm coming from cryptography, both to software engineering.
Yeah, and it was actually really fun because we, Ruslan and I, we met each other in real life. And last year, when like real conferences was a thing, we actually, like, I was one of conference organizers at NonCon security conference, and Ruslan was on stage explaining the details of designing this Ukrainian cipher. It was really cool.
These real life conferences, I've heard of these. They sound like a lot of fun.
Yeah. I have some memories,
Yeah, the distant ones from a long time ago. But yeah, so thank you both for sort of coming along. My background is in mathematics, but like not in cryptography. So I miss and don't know certain things, and then other things I'm like, this is quite straightforward. This is really nice. So it's nice to have like sort of a good spread of like sort of activity and interest and people who are doing some really cool stuff. I really love what you're both doing. So thank you very much. So I thought we'd start with a really easy question, which I got from Javier, which was, What is your favorite crypto algorithm and why is it base 64?
Well, for me, it's definitely base 64. Like, this is the best. And okay, so disclaimer, right? I maintain one of these open source cryptographic libraries, and we have really, really a lot of questions coming from developers, questions that they can't, like decrypt the data. And usually, like typically 99% of cases is not encryption mistake, is encoding mistake. Because, data encoding, when data is encrypted, it's two large topics mixed together. And this is like a real source of confusion.
Yeah, so I think that leads us into a good question, Ruslan. It's kind of a generic question that I get asked quite a bit, or I see coming up quite a bit, is how do you like assess and maintain and choose a cryptographic library for an application? So you're a developer, you know you need to do some encryption, but how do you work it out, Ruslan? Where do you start?
Right. So I guess it depends on what you're trying to achieve. If it's what I would call a commodity crypto, right? It's basic encryption, basic signing, or like something that's already well developed and well studied. You already have some mainstream choices, right? And you should obviously choose a well-established popular library. Even if there are some vulnerabilities that will get discovered there later on, they will be quickly fixed, and it's going to be a big deal. You're going to learn about it. So it's pretty simple. You choose either OpenSSL or Lipsodium is another popular choice nowadays. There is also Google Stink library. You basically just go with the mainstream. The problem is, what do you do when you are looking for some very niche kind of crypto, which doesn't have much implementations in like mainstream libraries? For that, I would say there is no like universal silver bullet. You gotta look at what's already there and who wrote it, what kind of background the people had. What I would want to warn you about is if something is written by cryptographer, it doesn't mean that this is necessarily a secure implementation, because just like developers sometimes make mistakes by not understanding crypto when they implement it, cryptographers make mistakes by not knowing the software engineering language enough. So it's sometimes there's always a risk of handling vulnerability. So use your best judgment.
That's a really important point. Anastasia, how do you work?
Yeah, again, like here I'm like super biased because I'm one of these, maintainers and now let's say contributors of open source library Themis, which is basically like a layer above like boring SSL, OpenSSL, etc. So I totally agree with Ruslan. Sometimes if you want to do just simple things, use like native cryptographic libraries available for a language and for a stack. However, often when applications are like multi-platform, it can get tricky to make sure that all your code across all these platforms can actually encrypt and decrypt the data, right? Because the native libraries can be different and their APIs are different. And the APIs usually are made by cryptographers. So I would say it can be a little bit tricky to put all these parameters, like lengths and buffers and think about padding and other things. So yeah, and to address this, for example, like we made Themis to address this particular use case when you need to do like something for like as a cryptographic library for a multi-platform application.
So that leads nicely into a question, which is actually from Robert Buchanan on YouTube, where he's saying sort of, can I be a casual cryptographic enthusiast? Do I need lots of mathematics? Like, how much crypto does a developer actually need to know to actually to develop a reliable and kind of robust solution in the real world? Like, question to either of you.
I would say that, if you don't mind, Sasha, I'll start. I would say that it depends on your background. Like, are you a computer scientist? Then I think even if you're missing some math, most of it you can pick up pretty quickly. If you come from completely different background, it might be a little bit more complicated. And then I would recommend, to stick to the standards and just use whatever math and algorithms and parameters are defined there, just to make sure, because even cryptographers sometimes screw that up. If you want to understand, though, there are some good books that kind of walk you through and introduce all the necessary mathematics. So if you just put enough time, you can certainly pick up and understand the things. unless you go into like quantum cryptography stuff, which is a little bit more complicated and requires physics as well.
I would also add that maybe on a high level, you don't even need to dig into math really a lot. If you want, if your goal is, you know, like to make to secure data, for example, in your application, right? Maybe you don't need to read about math, and maybe you don't even, sorry for me saying that, but maybe you don't even need to fully understand how ciphers work, right? But what you need to have is a basic understanding of risks and threats, because cryptography is not like it's not like a magic wand that will make your data protected. No, if you encrypt the data, even using like best of the best cipher, but you put the encrypted data and the key in the same place, sounds silly, but it's like typical mistake. Sorry, right? Even if you're good, like have a good mathematical background, but you don't use these things correctly, sorry. If you're building like multi-platform system, huge infrastructure, but you can't make sure that the data is encrypted all the time, and on some point it's like plain text, for example, and it's get into logs, it gets into backups, sorry, your cryptographic knowledge doesn't, you know, help you here, because it's like more high level stuff, more like risk management stuff.
Yeah, there seems to be there's a lot of plumbing, engineering, like sort of stuff that you need to be aware of and that you need different inputs in. So it's kind of like, I mean, there's a nice comment from Robert Buchanan saying sort of, is crypto a lifestyle? And I think actually maybe it is. I don't know how glamorous it is, but I would not judge me. Yeah, I would not judge it based on me, but I think, do you agree that sort of it's a thing you have to immerse yourself in if you're going to do some of it, and you have to like keep aware of it? Like, how much do you end up doing sort of on a week by week? Like, do you live, breathe crypto? I know you probably both do, but how much should I do if I was a developer?
I'd say if you're just like with security, crypto is also part of security, and that's the process. So yeah. So you kind of just want to stay aware of what's going on around you for sure.
Yeah, agree. And as a process, it has no end, right? And what I really like right now is that there are so many exciting things in cryptography, like zero knowledge proof, zero knowledge snarks, right? Some things like post quantum, right? That only few people understand, and it's so fun to read and, you know, try to apply the thing. So at the same time, you kind of can have this fear of missing out, because the industry is expanding. There's so much research going on, right? And at some point you can say that, yeah, I do have this knowledge, but I have completely like nothing. I do not know like anything about this domain at all.
I think I need a t-shirt that says crypto FOMO. I think I need that as a thing in my life. We might have to get onto Teespring after this and sort of get some stuff going. But I think that's a really important point, that there's a lot of stuff going on. I mean, we saw that NIST are now down to their selection round last week. So, you know, what was DES became AAS, and now we're into the next one, whatever they're going to call that. So like, you know, this is an ever evolving theme. So one question that came up in the kind of the pre-sale for this was, so how do you choose and maintain good knowledge for TLS ciphers? That seems to be quite a hot topic. A lot of people were clicking this on the vote on Twitter earlier. So like TLS is obviously everywhere. We're trying to get everyone from TLS 1.2 up to 1.3, and it's kind of edging slowly and taking over. I'm sure we all here are aware of the benefits of TLS 1.3, but like sort of where do I start like choosing ciphers? What should I avoid? What's good and what's bad? I'll take any flaws, and I've got some input afterwards.
So the best thing about TLS 1.3 is that you don't have to think about that much about the cipher suits anymore, right? Because we used to have around 20 of those. Now you just have 5, and most of those are just variations of the AES. So I guess the best advice would be upgrade to TLS 1.3. The problem is that most, you know, you cannot get rid of all of your clients who are still not compatible. So you will have to maintain 1.2 for a while as well. For that, I would say there are already some people who put a lot of engineering effort and thought it does that, and created recommendations on which ciphers to use and which particular Nginx or whatever server you use configuration you should use, and you should just be guided by that by those recommendations. I know Firefox has a great website to just you put in what you want and it'll show you like server configurations that you can just copy paste. I think that's the best thing to do.
Yeah, I agree. And the guide from SSL Labs, right, with like huge description of what you can choose. And yeah, I also agree with Ruslan's point that unfortunately, like we're excited about TLS 1.3 and we want everything to work with that. Sorry, we live in a real world with a real application, with a real infrastructures. Imagine that some databases like Postgres or MySQL, almost like recent versions, or maybe like latest -1, still does not support 1.3 at all. So even if you really want to, you just can't update to new TLS until you upgrade all these versions, of your like software, of your databases, do proper migration, make sure that you solve all the use cases just to upgrade the TLS version.
I think there's also some, so when PCI DSS changed their regulations that you had to drop, I think it was TLS 1.0 at one point, or TLS 1.0 and 1.1. A lot of people had the same solution, which was just, well, we'll put a NetScaler in front of it, and then that will do the TLS, and then I don't have to worry about it. But then you also have to consider, well, what if that goes down? If that goes down, then you're exposing the really bad TLS again, and you need to take into account all the things that could go wrong that you can foresee going forward. Look at your threat model, look at your attack surface, and just really pay attention that the crypto is not just appropriate, but also that if things go wrong, then things are, so that there's things behind it that'll hopefully back it up and keep you safe and keep your clients and customers safe. So I think that what you're saying is really important.
Yeah, you remind me about Apple approach. Right. So if you're like iOS developer and you want to submit your iOS application, you need to use certain TLS ciphers, and what TLS use and what Apple does, they just deprecate. I believe they deprecated 1.0, 1.1. So right now you can choose from, I'm maybe mistaken about 1.1, but I think you can choose from 1.2 or 1.3 only. You just can't, upload the application if you use like bad old TLS, right? And basically their approach is similar to what regulations do in the market, but the difference is that Apple is like a huge, it's called like vendor of this kind of ecosystem, and they push users like developers to update the TLS they use. It's like, this kind of approach. It's not like just a regulation or like laws, but no, we'll strictly like disable these things for your, just to make life easier for everyone.
What do you think about that kind of thing, Ruslan? How do you temper like real world requirements with cryptographic kind of best practice?
It's always a trade-off, right? It's like in security and risk management, you cannot eliminate all the risk. It's always, I think for most, if you're working in a company, right, if it's not your pet project or your kind of, I don't know, some non-financial stuff, right? If you're doing it for profit, then I think it should be driven by business requirements for sure. Like you cannot say we're not going to support this client because they are in TLS 1.1 if they're your largest client and paying you the most money. Unfortunately, like we would wish to, but that's the reality. But then when you do have to support these like legacy clients, right? You do want to make sure that you provide configuration for the server or whatever it is that kind of mitigates the known threats. And that's where it actually creates a new, more interesting engineering challenges, I would say, because it would be very simple to just say, hey, use the latest, greatest stuff, which does not have any known vulnerabilities, but you got to figure out how to protect the stuff that's older.
Yeah, exactly.
Yeah, I also believe that like cryptographers and crypto engineers and those who work in academia, they are very different. Like this is separate bubbles, right, from like software developers. And sometimes things that make me excited about, like in cryptographical sense, they just nonsense for software developers because they live in a different world, because they just can't use these things yet. The library is not there. It's like the use case is too narrow, and we should think about performance. So, right. So I would say that probably, again, depends on threat model, yada yada, but probably for applications that operate on sensitive data or that work in certain industries, you might want to use, like industry proven, old-fashioned a little bit, like ciphers and ways, like standard, I would say. And for like smaller applications, maybe for more like startup like, maybe for like pet projects, you can experiment with new and exciting things, but just try to measure amount of like money in fines if you use something new that will be broken recently, right?
I mean, that leads me to a question that I kind of had in mind, kind of more broadly speaking. So, like there are now frameworks like OWASP ASVS is one particular framework I'm going to reference here. And I know people who've worked on that, and they're really smart, really good people who have sort of produced this thing, which is like there's 3 levels, and if you're at 1 level, you need to do certain things. So I think I want to put the question to both of you: is the question more that we have to like sort of find levels of, well, if you're ASVS level 3, say, then you should be doing this kind of crypto. There you have to use TLS 1.3 and you make it mandatory there. But if you're doing things at ASVS level 1 or something with a reduced threat model and reduced attack surface, and then you can sort of break away from that. Would that be a worthwhile exercise to try and show people that crypto isn't an absolute either? Like there's actually various shades and various things. What do you guys think of that kind of thing?
Sasha, you want to go first?
Yeah, sure. Personally, I believe that this idea is really great. Is super useful. Of course, when you have only 3 layers, you kind of oversimplify things, right? Because every like application infrastructure and like business goals are different. But still, when you have these 3 levels, you can measure how much effort you can put into security, and you can talk with like business people, business owners, and to show them the levels, to show them which ISVS like questions you should consider done, right, if you are application of this level. So I really believe this is a very good idea, and this is a very good tool. But yes, again, this is like oversimplification. So yeah, for most application it will work, and I really like it.
Yeah, I agree that the default approach for sure should be kind of this prescriptive instructions, like you gotta do this, you gotta do this, you gotta do this, just to achieve some minimum level. Because it's very exciting always for for cryptographers, for someone who's enthusiastic about security in general, to kind of dig in and figure out, okay, what we need, what are the best tools we can use, what's the best approach here. But often, especially like for startups, they are not. Security is not their concern. Security is just something that they need as a side effect of of providing their core value. And in that case, unless you're going to just very explicitly instruct what they should do, right? They're not gonna dig deeper and figure out what kind of library or what kind of level of protection they should implement. So because that's not their intent. They are doing something completely different, which is providing value to the business, but they still gotta protect it, and they always want to make the minimum effort possible to meet some kind of security. So instructions, you got to do this and that, would definitely help in this scenario.
That's a really important point. And also I see, so talking about startups is a really interesting one, because I mean, crypto is more than just ciphers. It's more than just, block modes and, sort of cool algorithms and lots of math floating around. There's also sort of things like key management, identity management, that kind of thing. So what are your views kind of on things like Vault by HashiCorp? There's another one that I can't remember the name. Is it KeepSafe? I can't remember now. But there's a few out there that are coming. They're cloud-based, and they let you sort of so you can't compromise a password for a thing because the password's changed every 8 hours or something. So like, how do you feel about things like that sort of manage keys and basically try and create a kind of zero trust environments even within the cloud, where sort of crypto APIs and crypto keys and sensitive secrets are kind of hidden away? How do you What are your takes on that kind of engineering?
I believe that this question itself can start, like a long holy war discussion. Because yeah, I really like this question. I would answer like, typical I know security architect would answer, depends, right? So it depends. It depends on your like risk and threat models. First, like personally, from my personal experience, personally, I was very, I didn't trust this kind of solutions a lot, because like imagine you put some data, you give like keys to some cloud infrastructure that is not part of your infrastructure, you can't control that, you don't know what's going on there, you have this insider risks for them, right, to be broken, all the things. And maybe it doesn't suit everyone, but then I kind of changed my mind a little bit, because think about it from different perspective. If you're like a company and you don't operate on a lot of like sensitive data, so security is your concern, but not like huge concern, right? Instead of having your own security engineers and your own team, like working and managing like internal key management solutions like public infrastructure, for example, you just kind of outsource these to trusted authority, and you can spend time of your team on security efforts, but different. Like in, for example, application level encryption, right? You can add something more valuable, like you can spend time of your people in more valuable way than just re-implement things that someone can do for you. And technically, they do have a whole team working on these issues day by day, right? So you won't have the same level of like engineering forces.
So I think when it comes to choosing whether it should be on-prem or in private server, private cloud, whatever, we often fall for what's called the zero risk bias, and that's what actually causes like people in the United States to buy out all toilet paper and like hoard food when quarantine hits, right? Basically, when we are faced with a lot of risks that we can mitigate all of them, what people try to do, instead of kind of mitigate a little bit each of the risks, so to kind of bring down the level of the threat, what we do, we tend to eliminate the simple risk, which we can eliminate, right? So you can buy as much toilet paper as you want and stock up for the next year and not have to worry about it like at all. But then there's nothing, like that's not doing anything with the coronavirus threat. And same here, when people say that no, we cannot afford by any, in any scenario to deploy in AWS or deploy cloud-based HSM or something like that, I think that's related, right? So you say this is a risk that we are mitigating like 100%, but then you still have a lot of risk connected with running stuff on-prem. You still can get hacked, and basically the reality is that the cloud provider might be much better trained and much better prepared to support the functionality that you need, versus you just figuring it out and deploying on-prem. So while you're completely mitigating one risk, which is like third party being hacked and you've been affected by it, you still have a lot of other risks to think about, and we should kind of treat them equally.
So how do you then deal with things like so I've read on the internet, and that means it must be true, okay, I read on the internet that we should all be worried about quantum, right?
I was hoping we would have enough time for this.
So this does actually come up, like sort of, just as in the sciences, like sort of there are fads, there are moments of things that are sort of being really popular. There's a lot of people really talking about quantum a lot at the moment. So let's just put the question there. I think we have our answers. How worried should anyone be about quantum? I'll ask you to go first.
I believe that we should be worried about climate change more than about quantum computing, to be honest. It's my like personal approach. But I would recommend to watch some talks by Jean-Philippe, because he has like really amazing presentation on quantum computing and or like quantum safe cryptography, right? And he basically outlines which ciphers will be broken in which way and what shall we do. So like increase key lengths, for example, or like switch to quantum safe cryptography. And also I like to keep an eye on Cloudflare, because last year, for example, they did like huge work on changing some things in TLS key negotiating to quantum safe, right? And they have this huge blog post describing which ciphers they took and how they measure results.
AWS have their post-quantum SIKE, don't they, as well, and things like that they sort of worked and pushed through. So I think there's interesting options that you can do to kind of quell that fear. Ruslan, how do you approach this this question?
There are also a few other existential threats that we need to face, right? It could be an asteroid, or it could be a explosion of the sun, which will definitely happen. But we still have some time. So I think in quantum, post-quantum hype, I think I'm taking a less popular approach where basically I think that it is important to research the math, which has been done for a while now for sure, because the math to actually break like factorization-based algorithm existed like for decades. But we still need a quantum computer to run it, because right now the algorithm is abstract, right? We don't have an actual hardware to run it. And we moved from having quantum computer with 0 qubits like around 30 years ago or so to quantum computers having 100 qubits nowadays. Talking about quantum computers that can actually run those kind of algorithms. To actually be a threat to cryptographic algorithms, we would need to have millions of qubits run reliably on the quantum computer. I'm not a quantum physicist, but I do like physics, so there is just a little bit of intro here. So I think right now, if you're a company or if you're basically a developer who's implemented stuff, you shouldn't be concerned about it in any way. The research community, the academic community, they are concerned. They are researching new algorithms that are resistant to post-quantum or to quantum threat, right? And NIST is in the process of choosing the standard that that would be if we ever need to face this threat, right? You would already have a standard available for you that's researched and you can implement it. So it's great to talk about. It's important for the research, but for the applied stuff, it's not yet. You shouldn't be focusing on that, because the reality is you probably will get owned because of some unbound, undefined behavior treated differently by compilers on different platforms.
You see, Mark, the problem is that like we're like applied engineers, right? We are not like hyped driven marketing people. However, I believe that quantum cryptography will be really useful if you wanna, build a startup and get a lot of money from investors. So you just say, yeah, we use quantum safe. Yeah, your data is safe with us, even when quantum computing is here. So we just underestimate this. This is a huge opportunity.
So you're saying that quantum is like the new military grade, like
post-quantum is the new military grade, yes.
Post-quantum is the new military grade. You heard it here first, folks. This is this is the real talk. This is the real stuff. So this is
T-shirts are coming.
I mean, this is what you were saying was like really pertinent. I remember I was reading a paper recently about from MIT, I think it was, where they reckon that we can get Shor's algorithm down to just 20 million qubits. And of course, we've all got in our sheds back there with the liquid helium, like we've all got a 20 million qubit quantum computer. So we just upload the new program and go, right? That's how it goes. I think that you're both absolutely right. There are other problems that need to be paid attention to first. Climate change being a particular pet of mine as well. I think that's really important. But I think that there's a lot of hype. And it's not gonna go away. So we're gonna have to keep sort of fighting and sort of pushing and going, look, get your TLS right first,
Yeah, exactly. Like make sure that you have backups. Make sure that those backups are not zero, that you actually can put data. Yes. Yeah. And then if you like encrypt backups, make sure that you can decrypt them back, because suddenly you can lose the keys. It is not backed up, right?
Absolutely, and that goes right back to the key management yet again. It's just making sure that I think the thing that people need to maybe do, and what I think hopefully is coming through, is that cryptography is a perfectly approachable subject, and that you can learn it. Yes, there's maths involved, but a lot of the maths tends to be justifying something or tends to be explaining something, like why is AAS hard to break in this situation or that situation, as opposed to you don't need to really understand the mathematics to implemented, to do the mixed functions, to generate the arrays and to do the shift rows and all that kind of stuff.
Or even to understand how it works, right? To understand how it works, it can be like, you can get familiar with this mess. It doesn't have to be like intuitive for you on like every level. It has to be if you try to implement, come up with a new algorithm, for sure.
I think exactly right. I think that's exactly right as a statement. I think that I want to move on to sort of something a little bit more kind of a fun question, which is, what is your favorite crypto flaw? And I'm going to go first. So I've done a lot of code review. I used to be a pen tester. I'm now a mathematician doing stuff with quantum, long story, and also with sort of security research. But I remember I once did a test where we managed to compromise a machine. And there was some weird encryption going on. And we were like, we've not seen this DLL before. We've never, this was like sort of, oh, this could actually be something interesting. Let's have a little look. So we got the DLL file down. It was in C#, so we just got in .NET so we could get everything back again. And we were looking through, and we noticed that the encryption function had a typo in it, encryption. So me and my colleague Matt, we were sort of looking through it, and we just looked at the code and we were like, huh. So we just copied the function name and searched on Google, and we found a page on Stack Overflow called How to Do AES in C#.NET. And it turns out that they hadn't just copied the algorithm, they'd also copied the key. Like they just copied the whole thing and put it in. And so we kind of had a word and said, can you maybe not run this encryption in your production system? And of course, now they don't, and certain questions were asked, and those people aren't allowed to do, or weren't allowed to do encryption for a while. I think that was just like sort of, emblematic of so many kind of just developer things. Like, we just need it to work. How do I do it? And this is why I asked about libraries earlier, like sort of, how do we choose one? And I think you give excellent answers. But that's my favorite story. I'll let either of you go with that.
Like, to be honest, when you were saying that, my first thought was that they have this algorithm, like function with typo, but they never use it. It was like my first like idea. Yeah, because this kind of like approaches I've seen, yeah. When people
Beautiful encryption, but like, oh, you never call it, so it doesn't happen.
Yeah. And then you just call base64, and if you can't read the output, it means it's encrypted.
Yeah,
right?
That's how it works, right?
Yeah, obviously. So
well, actually,
yeah.
Go ahead.
No, please, Jen.
Okay, I was just gonna jump in, like when we were back to encoding and base64. To my surprise, if you actually go to Wikipedia and open up the encryption article, it says that encryption is a process of encoding, which I don't know, like, what about other schools, but like in post-Soviet countries, if someone would say that, like, you would go like, oh, no, like, encryption requires a secret material, right? It requires a key. Encoding works on plain text data without any secret material. So that's the difference. So you cannot say that encryption is encoding, but Wikipedia does say so. Wikipedia is not always right, I guess, what we can learn here. And in terms of like popular bugs or like things you catch in implementation, I think for me, the most popular was for sure the misuse of random number generators. And typically people use the one that's just supposed to be used for like statistical analysis that just produces the necessary distribution, but it's not actually cryptographically secure, because like most of the time that I had to deal with, the algorithm is secure and the library is secure, but whenever you need to generate the random data, that's where it comes to to a stop.
Yeah. Regarding encryption and encoding, I had some thought in mind. Well, anyway, let's get back to crypto flows. I've seen a lot of like this putting password or putting key somewhere near the data, like happens all the time. Putting key right inside to the crypto envelope, right? Because we will need to decrypt this data somehow where we will get a key. So let's put the key near the data, obviously. But this has like quite simple ones, right? I had really nice, I've seen really nice cryptographic flows with, I don't know, bits leaking. I really like the side channel attacks where some, small bits are leaking on each round, and then you can like combine them. This fascinates me, honestly, because this is something that might be really complicated to understand, like to build like a mind map how it works. I also like all these bugs where some bits or maybe bytes even are extra, and with this extra bytes you can actually like put something there. So this is not like a direct bug, but you can use it to build some like some malware, let's say. So I think that in cryptographic computations, because you need to work with memory, and it's very easy to misuse.
Yeah, I mean, my background is embedded systems. So once Colin O'Flynn released his Chip Whisperer, I was like, this is the best thing ever, because you just listen very carefully to a microchip and it tells you its secrets. I think it's amazing. And sort of, how do you mitigate that? How do you work around that? What do you have to do to actually sort of stop that from happening? I think that's it's a really, really fascinating question. I fully agree. That's a really wonderful part. Looking at random number generators, Ruslan, something you mentioned. I remember I was doing some stuff about the contact tracing apps, and I noticed that one of the implementations was in Kotlin, and it was that day, I was that many days old, when I found out that Kotlin doesn't have a secure random number generator of its own yet. They simply wrap into the Java secure random number generator. So yeah, like sort of even in a language as established as Kotlin, you can still have things that are missing, and that's okay. So not dirty hack. It's a very nice kind of clean, straight pass through. But yeah, there's an interesting issue discussion thread about that on the Kotlin GitHub pages. So that's
if you could send it to me afterwards, because my team is actually considering Kotlin for future use, and this would be a nice input.
We'll send it to you, Ruslan. Not a problem.
But you actually can use this API from Java. So they have this interoperability. So if you know what to use, you can be fine.
Yeah, I think they were looking for candidates in the issues that Kotlin could have its own. But I think some of it ended up going, why don't we just use the Java one? Like, because then it's sort of someone else's problem maybe. I don't know. I haven't looked at the thread for a while, but I'll dig it out and send it over and put it in the chat. It's an interesting thing. I just think that we're still learning, we're still developing, we're still building, we're still sort of engineering solutions, which is why I admire what both of you do so much. I kind of sit on the fence breaking things and breaking encryption on microchips, and then people say, but how do we fix it? And I'm like, for that you might need to speak to a real expert. So I'm I'm always grateful for this kind of input. I'm just looking through for yes.
Well, yeah, one more interesting bit about this, like modern high-level languages like Kotlin or like Swift, for example, the immutable strings, right? The immutable strings are for the good. But if you work with cryptography, and if you have this random idea to take some kind of like cryptographic key and to use base64 encryption, for example, encoding, sorry, and you see, and put it in a string, here is the problem. So the strings are kind of immutable, so you don't own the process how to wipe out, how to delete the content, right? And you can use like perfectly fine cryptographic library. You can write perfectly fine cryptographic code, but you can't control the whole like flow. You can zero the data, you can wipe it out. So you need like your cryptographic code should be written in consideration to the language itself, and maybe you should not use strings in these languages like to put keys or secret data in them.
I think that's really important. Do you have are there like sort of set resources for individual languages for like how to do type referencing safely for cryptographic functions? I know there's a lot of activity in the Rust community along those lines, but for other languages like Kotlin or Swift, are there any resources you know of?
Well, I know that Jean-Philippe has his crypto coding guidelines, and I actually remember them because I added some lines about Swift, like exact this use case about wiping data. But mostly crypto coding guidelines are for C languages, like C language, but there are some things that you can find and you can use in your language.
Exactly. So I'm going to just throw a bit of a curveball, because this is an interesting question that has sort of come up, and I think it relates to another question that's sort of going on there about a sort of formal verification of systems. So I've looked at formal verification, and I've looked at sort of the way that these things are going. Do you think it adds to things? Does the output of a formal verification step help when you're developing a crypto standard? And if so, do you have any hints and tips, or do you look at it and go, we're not entirely certain? Like, so what are your responses to that?
I think basically the formal verification for the protocol is like a linter for regular code, or static analysis for like regular code. It helps you to avoid some already known issues, given that you can properly describe the model. Depends on which kind of formal verification you do, right? But in some of them, you need to first describe the protocol, and then you need to actually describe it correctly. So there is like meta thing going on here, right? Is your verification model is correct? Like, how do you verify that your verification model is correct? So by all means, it's not a silver bullet. Yeah. And we had like a story with TLS 1.3, which was formally verified, but there were some omissions in the model, which caused to kind of some minor flaws, I would say, in the protocols that were addressed later. But as with code, as with everything, I would say formal verification is needed, and it helps a lot. But it's not silver bullet that's going to solve everything for us. Just like static analysis of the code will help to address some bugs, but it's not going to make our code bug-free completely.
Yeah, I totally agree with Ruslan. And I would just add that similar to static analysis with the code, you need someone to keep an eye on that, right? So similarly with formal verification, you need like experts, like people who know how to do this, like to rule the process, to get back, and to keep an eye. Otherwise, it's just a tool. If you use it correctly, you have some results like helpful for you. If you misuse it, or like if you don't build the model good enough, like, sorry, you tried. And the bad thing here is like illusion of security, right? Because you tried, you put a lot of effort, and you believe that you did everything right. So you kind of unknown. You don't know what was wrong.
Yeah, and so I think what you both said is really, really important about formal verification. That as long as you are complete with your verification, then you'll get out. But if you miss something in, then you're going to get. And if your input is incomplete, then your output is also going to have a level of incompleteness. And I think it's very important to remember that you can't ever be 100% sure that your formal verification means everything is safe and it's only butterflies and bunny rabbits and birds and beautiful fields. No, you have to be careful and always double check, always recheck. And get others to check what you're doing and sort of have a look at what's going on, and just make sure, and then wait for that moment, usually either at 4 a.m. because you can't sleep, or when you're sort of standing there in the shower with, you're doing your hair, and then suddenly you get an idea. It's why a friend of mine keeps a whiteboard marker in his bathroom, because he makes notes while he's having a shower. He's the only friend I know who does that, and no, the friend isn't me. So just so we're all there.
Of course.
Yes, you believe me, right?
Sure.
You can verify that.
Yeah. Absolutely, yeah.
So I have one question that's kind of unusual, and this has come up. This is from a friend of mine, David Albone, who kind of said he's reading his stuff about fully homomorphic encryption, and he's like, so I'm reading about this, and I'm like, are there any like real practical uses? He seems to think of this as a kind of a beautiful mathematical exercise that is good for mathematicians' grants, not necessarily for our engineering budgets. So what do you guys see a future where fully homomorphic encryption saves the day in a Hollywood film?
I would say it probably would not save the day, to be honest. There are some very interesting properties that homomorphic encryption allows, right? But there is an inherent problem with it by design that it's malleable, meaning that you can, it's very hard to authenticate the data, even though I've seen there are already some schemes that kind of try to combine with other techniques to allow to do that. But basically, the idea is that it's like textbook RSA, where you can modify the ciphertext and it will get decrypted to a valid input, but to a different one. And initially, it doesn't seem like a big deal, but in many scenarios, it can cause a lot of trouble. And with homomorphic encryption, it's very hard to avoid that property. So it's hard to say for sure. Maybe in the future we'll discover some scheme that completely solves that problem for us. Like, for example, I know that some research driven by the quantum hype, right? Some research in quantum algorithms actually produce algorithms that also have interesting properties from point of view of homomorphic encryption. So maybe we'll have some progress there. But until now, aside from that, homomorphic encryption is very slow. So it's nowhere near with efficiency of like classical encryption algorithm. So it might have a very good use case in some niche, narrow use cases like scenarios to solve some problems, but I don't think that it's going to be like a silver bullet that once will switch everything to it and we will forget about data leaks. I don't think that's going to happen.
And you, Anastasia, a great use for it yet?
Unfortunately, like we are probably the bad people to holy war about topics because
most boring cryptography.
Yeah, like the idea is nice, but it has some implications during implementation. So yeah, like depends, right? From my experience, a lot of people ask, like as a company, about homomorphic encryption when they ask about searchable encryption. So this idea when your data is encrypted, but you can still search in this encrypted data. And sometimes we are talking about really simple search like exact queries, and sometimes like people want to have this magical search, like full text search on encrypted data. And homomorphic encryption is being like mentioned in these discussions as something that could potentially save, like answer these questions, right? But as a company, like, and myself, I totally agree with Ruslan. Homomorphic encryption is a good idea. It has some like fully homomorphic encryption has some niche. It can work in some narrow cases and niche cases, but for most industry, like industrial applications, especially when you want to have like encryption of data, which means that you will have a lot of things going on, right? It might be too slow, and it might be like as you need to have like a totally separate like cryptographic management infrastructure to support this. So too slow and too much things to think of if you want to maintain the solution.
I think those are really good takes on it. And one thing I will say is that sort of fully homomorphic encryption, I think the best example is based on lattices, right? So what the question I think we need to sort of start looking to round off our session, and I think I'm going to pose this question to you. So NIST, as we mentioned at the start, they are selecting, and they're selecting post-quantum, and they're selecting all these very cool things. So where do you guys think that things are going to actually go? Do you think that it's going to be like a lattice-based crypto, or is it going to be team super singular isogenies and elliptic curves?
It's hard to say because basically that math evolved a little bit after my time at the academia, right? So I'm not very up to date with. We did have some lattices because NTRU already was a scene back then, but since like with super isogenies and stuff, we did not have much of deep dive into those. So it's hard for me to give like an informed opinion on this particular math, right? It's going back and forward. Like if you keep an eye on discussions and stuff, it's like people do have their opinions, right? Someone says one is the best thing, and it probably has to do with who developed what kind of scheme, for sure. But I think it's good to have general like progress in the research field. There are basically we're just discovering some new things, right? And as you mentioned, right, lattices, for example, do provide some interesting properties like for homomorphic encryptions. And even back to homomorphic encryption itself, while it's not going to be, I don't think it's going to be a big thing in its own, but maybe at some point it's going to be stitched with a number of other techniques or algorithms that will provide some new, very interesting values, like with digital currencies and Bitcoin. There was no new cryptography developed back then, at least. Now there is a lot of research in the field as well. But basically it was hashing, encryption, and signature, nothing new, but it was combine together in interesting ways that would provide some interesting new properties. And I think it doesn't really matter which kind of algorithms we'll stick with. We might go with isogenies, but then lattices will do a strike back after a while for some other use case like homomorphic encryption.
So which one do you think will win though?
We'll see. We'll see.
We'll see.
Anastasia, do you have a better? Because this is one of those cases where I'm like, it's a 50-50 chance.
Well, for me, I'm even in a worse position because I don't have this, formal cryptography education. So I'm completely an observer of the whole discussion. I'm like, okay, so this is interesting. Oh no, this idea is also makes a lot of sense. And I stopped, making here my own choice. I'm like, okay, I may be, not qualified to talk about these things. I will just, take a step back and look what's going on, because sorry, people are already discussing, they have their arguments, let them show. And but I think that we might have maybe something new, the new approaches, because I really like this Ruslan's thought that maybe some approaches will emerge and we will have some new things based on all things with qualities of new. So yeah, I would say that this might be the solution.
So
I would
oh, sorry.
I just wanted to add quickly that I wouldn't also call whoever gets picked by NIST, I wouldn't call that a total win yet, because first there is certain level of distrust in NIST right now after 2012, or which year was it? So it's just one body, and we also have ISO, we also have just the community, Bernstein ciphers kind of jumped in, without any formal standardization first and got popular and were standardized after the fact, specifically because of this level of distrust. So we'll see. It's an interesting ride.
That's a really, really good point to make, actually. So I'm a mathematician by background, so I've read sort of some of the background papers, and I am going to put my stake in the ground to give this some kind of round out. So, but I'm going to give sort of a two-leveled answer. So I'm going to say that super singular isogenies, for those who don't know, basically guarantees that the background group on your elliptic curve stuff is really big. So you've got generator sets of at least 4. So it's really nice kind of mathematics. And I personally think that the super singular isogenies is the more beautiful of the mathematics. And I can already feel, I could feel the disagreement, but I think lattice, because of properties to do with the fact that it lends itself towards homomorphic encryption with given examples, and I think that because of the way that it's being implemented, I think lattice has got the edge in terms of the engineering advantages. I think they're both beautiful systems. One is slightly better mathematically, but I think that lattice is going to possibly win out a little bit, or certainly it might win a few hearts, even if it doesn't win a few races. But only time will tell. I think only time will tell, and I don't know. If I'm right, I'll capitalize on Twitter later in about a year's time. But if I'm probably wrong, so don't place any bets based on what a crazy long-haired mathematician in London says.
Nice, yeah. Whatever gets standardized, I think the winner is the one who's actually gonna get widely used if we ever get to that point.
Yeah, and we'll see how that bridge goes when we actually come to cross it. I think that's been an absolutely stellar discussion. I'm gonna start drawing to a close and just sort of say that from my point of view, I am greatly indebted to you both. Thank you so much for agreeing to do it. It's been an absolutely, I've enjoyed it. I hope you both have too. I hope people watching have also had a nice insight that, cryptographers are wonderful people. It's always been my experience, and crypto engineers are sort of actually cool people to have around and to party with. Well, maybe not at the moment. We'll have to wait for lockdown. Maybe 2030, 2040. I don't know when it's going to end, but one day I'm sure we'll have conversations in real life again. But thank you both so much. Also, thank you to Matt for putting this on. I'll keep an eye on any extra questions, but I don't see any. Matt, have you got any questions for us?
Yeah, thanks for the roundtable. Actually, I also enjoyed it. It was quite entertaining. Yeah, no, like no question, just some comments to the point Ruslan was saying about startups. It's true, like most of startups don't really have like security is not really pretty high on the priority, and they can just put in we see it often, like they just say like, oh, it's secure by default in their press release, and that's pretty much it. I mean, we have seen it with Zoom. They kind of waited a long time, but they're definitely not an exception, and they were quite big. They were like post IPO when they started to focus on security. And all the talk about like end-to-end encryption was also like quite interesting. I'm pretty sure we're gonna hear about people diverging opinions on end-to-end encryption for a while, and it does remind me, once I was having a discussion with someone about end-to-end encryption. I was like saying, well, end-to-end encryption is it's quite good. It's like, no, it's broken. I'm like, what do you mean it's broken? Which one is broken? It's like, no, I've read it on the internet. It's broken. I'm like, okay, send me the link. And it's like, no, it's broken, but there is a better algorithm. It's like, oh, really? Tell me. It's like the OEE algorithm. I was like, what's that? And I googled it. It's like the one-end encryption by vORC. It was like a pure troll. It was like this like GitHub repository thing. This is actually it's pretty funny. Let me just.
Is that also JP's creation, one-end algorithm? I think
yeah. vORC. Yeah. It's like, this is secure against hostile endpoints. OEE is post-quantum, quantum safe, quantum resilient. OEE is secure even if P equal NP. OEE is post-nodal and NSA proof. OEE is gluten-free and non-GMO. It's like OEE is probably secure. I was like, oh, it's definitely a troll. And then I was like, did you read all of it? It's like, yeah, I read it. It looks really good. I was like, oh man, like if even people who know like about software and development don't even understand what's a troll from not a troll, you know, like it's becoming dangerous. So imagine when you know, like when there's something like Zoom happening and people are like, well, is it really secure, you know? Like then you're like, well, it depends. What do you mean, you know? Like they're like, oh, should we use like this other app instead? You're like, well, because like the interesting thing that happened with end-to-end encryption is it's actually becoming a mainstream discussion, you know, because you know, like although like TLS, like because of HTTPS and everything, you could say like it's becoming more mainstream, but like end-to-end encryption is in the news a lot. Like I don't know if you guys have seen like the Anchor chat like shutdown that happened. Was it in France and Netherlands? That was pretty interesting to follow. I mean, it's kind of cool to see like there's more and more people talking about like crypto and like security and all those things, that, you know, it's just not a very like small pocket of people like being actually interested by it.
I think my to talk about end-to-end encryption, one of my favorite stories is someone once I overheard a conversation where they said, "Oh, end-to-end encryption, what's that?" I just said, "Oh, you just encrypt it." "Oh, yeah, end-to-end." And that was his complete explanation of end-to-end encryption. So yeah, I think there's a lot of education that needs to go on, and there's a lot of discussion around things. And I think that hopefully AMAs like this and the ability to go, look, we'll answer questions, we'll see how things go, and that's important. And thank you very much for the platform, Matt. It's been fun.
Well, thanks to all of you for joining, and thanks to you, Mark, for like moderating and driving the discussion. It was very interesting. Maybe the next one, both of us will go to Ukraine so we can do it physically with Anastasia and Ruslan.
I think that's the obvious conclusion.
I'll have to go to Ukraine too, though, because right now I'm in California.
Oh, okay. Well,
yeah, so we can meet in London, you know, like in the middle of the world.
Neutral territory, yeah.
Yeah.
I was kind of looking forward the pierogi and the okroshka, like in London, you know, like the beers.
And borscht, of course. Yeah, my pleasure, and thanks a lot for inviting us as well. It's been a great discussion.
Yeah, and I really enjoyed the questions from the audience, like in the chat. Yeah, thank you.
Yeah, not
Thank you.
you guys. You all were great. It was very cool. Well, thanks again for joining, and yeah, I guess talk to you soon.
Take care.
Take care. And we are getting to the end of today's episode, which is, like I said, the last episode. Quick reminder. So the Discord server is still gonna be available. Let me see if I can just put it here. Yeah. So the Discord server is still gonna be available. So do not hesitate to join it. Actually, there are people like watching on Twitch. That's cool. Yeah, definitely subscribe on Twitch. If I do some live stream, I think it's just gonna be like ad hoc, and definitely on Twitch because it's easier. And some of the discussion also are also on Spotify on the podcast. Because like the previous group was just saying, there's definitely a lot of educational work to be done. So I mean, I think Spotify is also a good platform for that. So obviously, the moment all the people left and who are watching now or waiting to know, is probably like with the winner for the complimentary Black Hat ticket. Well, so that was Timo Kroshka. That's pretty funny. Yeah, so well, that was pretty easy to choose, at least to collect the data, because only like 3 people tweeted with the hashtag, and based on the rules. So just have to pick between the 3 people for the complimentary ticket. Yeah, so congratulations to you, and I hope you're watching now. So that's Ramblina, yeah. So you won for the complimentary ticket for Black Hat. So I will send you a Bosch for sure. I will send you the information in DM on Twitter for the complimentary ticket. So congratulations again to you. And yeah, if if you have any question or suggestion, like if you have suggestion for like a new format, definitely like send me a word. I'm open to listen to it. So like I was saying, like I was like thinking, I had the goal when I started the live stream is to be like, okay, I'm gonna give like 10 virtual conference every 2 weeks, and I'm gonna stick to it, just so like to not bail in between. So that's what has been done. All the material from the previous edition is available on YouTube in the integrity for free. So that's also I think it's pretty cool. There's definitely a lot of material now to learn. And yeah, like I was saying, also the Discord, which is right above my head now. Come join the server, and do not hesitate to ask questions if you want to learn more about security or software development and all those things. And yeah, I guess that's pretty much it. Yeah. Let me check the chat actually. But yeah, congratulations on a really good series, 10 out of 10. Well, thanks, Mark. I'm sure your favorite was the last one. But yeah. because yeah, I do think like streaming is pretty cool. There's definitely a lot of like potential for like a lot of like cool material. But yeah, definitely need to get some ideas about like some potential formats and stuff, because as long as it's educative and interesting, I think it's definitely worth it. Even myself, I enjoy like presenting like 2 weeks ago when I was giving myself a presentation here about the ARM64 like Windows exploit I wrote. I found it like more practical than actually going to conference. Although like I guess at some point we all gonna go back to like physical conferences. But like Mark was saying, we don't know when it's gonna happen. It seems like there's a second wave now. Should have gone for 0 out of 10. yeah. Thanks, Laura, for watching and being a good supporter since the first episode. But yeah, like I don't think it's kind of cool, that you can actually like speak to some people and like kind of share it. Like I was saying, like the problem now, even like with Twitter, is still nice, but it's getting like very noisy, so it's kind of hard to like filter out. So no, enjoy them. Well, maybe it should have gone for 0 out of 10 if you enjoyed them more than Jason. What do you mean? But yeah. That's that's pretty much it. So I don't know, like, do you have any questions or comments for this last edition? Any feedback? Trying to see if actually, I should probably message that person who just won now. Like it's probably wondering why. Actually, did he commented? When no, is when are you doing it again? Well, there's no. I mean, I'm saying like yeah, there is no other like new session, so I won't do any again. Maybe I'll do like some ad hoc like chat, just like a single format, some random dates. That's why like definitely subscribe on the Twitch, because I think I'm just gonna stream on Twitch anyway after. Like the main reason I was like streaming on YouTube initially is because I knew like everyone has a YouTube account on Twitch. Like there were not as many people using it, but definitely not sure when I will stream again. But for UpCode 2020, for the virtual summit, that's definitely the last episode. So for the video from today, so there's like the full integrity of the live stream, which is already available now, and the slides from the first presentation are available on GitHub. Well, will be available on GitHub because I still have to upload them. And if you want the slides from like the previous conference, you can just get them here. So if you go on the UpCode GitHub, all the slides are here. So you can find all the content here. So you go to 2020, July is like all the dates. So I will add it tomorrow for the first presentation. And there's like all the other like edition, and also like previous years also. But yeah, so that's basically how the content is organized. It's everywhere. It's all over the place. But yeah, cool. Well, if there is no more questions, I guess that's it. I will say bye to all of you, and have a great summer, whatever you're all doing. So yeah, bye, and enjoy the rest of of July, soon to be August.